Have you ever stood ankle deep at the edge of the ocean, felt a wave curl around your feet, and noticed that sharp, unmistakable taste the moment a drop touches your lips? It happens instantly. Salt. It's so familiar that we barely think twice about it. The ocean is salty. It feels like one of those facts that has always been true, like gravity pulling you down or the sun rising in the east. But that assumption hides something incredible. Earth did not begin with salty oceans. In fact, the oceans we see today are the result of an unimaginably slow transformation, one that unfolded over billions of years. So, how did the ocean become salty in the first place? And if rivers are constantly feeding into it, why don't they taste the same? The answer is a long, patient story written by rain, stone, fire, and time itself. To understand why the ocean is salty, we have to start with something that seems almost unrelated. Rain. When rain falls from the sky, it looks pure. It feels clean. But rainwater is not chemically neutral. As water droplets form in the atmosphere, they absorb carbon dioxide from the air. This creates a weak carbonic acid. It's mild enough that it won't hurt you, but strong enough to matter over geological time. When this slightly acidic rain hits the land, it begins a quiet but relentless process. It reacts with rocks, not explosively, not dramatically, just slowly, molecule by molecule. This process is called chemical weathering, and it's one of the most important forces shaping Earth's surface. As rainwater seeps into cracks in rocks and flows across soil, it breaks down minerals locked inside solid stone. Sodium, calcium, potassium, magnesium, chloride, and many other elements are released in tiny amounts. These particles dissolve into the water, invisible to the naked eye. Streams carry them downhill. Small creeks merge into rivers. Rivers grow wider, deeper, and more powerful. And every single one of them carries dissolved minerals along for the ride. That means every river on Earth is ever so slightly salty. Not enough for your tongue to notice, but enough for chemistry to care. Now here's where things start to diverge. Rivers don't keep this salt forever. They are moving systems. Water flows forward, always towards something lower. Eventually, nearly every river reaches the same destination. The ocean. When river water pours into the sea, it brings its dissolved minerals with it. And then something crucial happens. The water continues its journey through the planet's cycle. The salt does not. Sunlight heats the ocean's surface. Water evaporates and rises into the air, leaving its dissolved salts behind. Clouds form. Rain falls again over land. The water returns, refreshed and mostly salt-free. But the minerals remain in the ocean basin. Over and over again, for millions of years, rivers deliver salt. And evaporation removes only the water. The ocean slowly becomes a giant mineral reservoir, collecting the chemical leftovers of Earth's continents. But rivers are only part of the story. Far beneath the waves, hidden in darkness, the ocean is also interacting with the planet's interior. The ocean floor is not smooth or static. It is split by vast cracks where tectonic plates pull apart. Along these mid-ocean ridges, seawater seeps deep into the crust through fractures in the rock. As it travels downward, it encounters intense heat from magma below. The water heats up, reacts chemically with surrounding rocks, and becomes loaded with dissolved minerals. This superheated water then rises back up through hydrothermal vents, spilling into the ocean like underwater geysers. These vents don't just add minerals, they also remove some. Certain elements are stripped from seawater and locked into newly formed rock. Others are released in greater concentrations. This constant circulation acts like a planetary-scale chemistry lab, adjusting the composition of the ocean over time. The ocean is not just passively collecting salt. It is actively being reshaped by Earth's internal heat, even miles below the surface. At this point, a natural question arises. If salt has been flowing into the ocean for billions of years, why isn't the ocean unbearably salty by now? Why doesn't it taste like a saturated brine? The answer lies in balance. While salt is constantly being added, it is also constantly being removed. The ocean has several slow but powerful ways of regulating itself. One of the most important involves life. Many marine organisms use dissolved minerals from seawater to build shells, skeletons, and hard structures. Clams, corals, plankton, and countless microscopic creatures extract calcium, carbonate, and other ions from the water. When these organisms die, their remains sink to the ocean floor. Over time, they become sediment. Layer upon layer builds up, eventually forming limestone and other sedimentary rocks. In this way, minerals are permanently removed from seawater and locked into Earth's crust for millions of years. Another removal process happens when seawater becomes trapped. Sometimes tectonic activity or changing sea levels isolate parts of the ocean, forming enclosed basins. In hot, dry climates, water evaporates faster than it can be replenished. As the water disappears, salt crystallizes and settles into thick deposits. Entire mountain ranges of salt found on land today are evidence of ancient seas that evaporated long ago. These processes act as pressure valves, preventing ocean salinity from endlessly increasing. The result is a dynamic equilibrium. Salt goes in, salt comes out. The overall salinity of the ocean stays within a relatively narrow range, and it has done so for hundreds of millions of years. That stability is one of the reasons complex marine life was able to evolve at all. Still, the ocean is not uniformly salty. Salinity varies from place to place, shaped by climate, geography, and circulation. In regions where evaporation is high and rainfall is low, seawater becomes saltier. In areas where large rivers dump fresh water into the sea, salinity drops. Near the poles, melting ice dilutes seawater. Near the equator, intense heat drives evaporation. Ocean currents constantly move water around, smoothing out these differences, but never erasing them entirely. Some bodies of water take this process to an extreme. The Dead Sea is one of the saltiest places on Earth. It has no outlet. Water flows in, but it can only leave through evaporation. Over thousands of years, salt has accumulated to extraordinary levels. You can float effortlessly on its surface because the water is so dense. The ocean, by contrast, is connected globally. Water flows between basins, mixing salt and keeping concentrations relatively moderate. So why don't rivers taste salty if they contain dissolved minerals too? The answer is time and turnover. Rivers are constantly renewed. Rain falls, snow melts, water flows through and out. The minerals they carry are diluted by fresh input and quickly pass downstream. Rivers do not get the chance to accumulate salt. The ocean does. It is the final destination, the end of the line. Almost all surface water eventually arrives there, and the ocean remembers what the rivers forget. What makes this even more remarkable is how deeply this saltiness is woven into life itself. Marine organisms evolved in salty environments and developed intricate ways to regulate their internal chemistry. Even humans carry a faint echo of this ancient ocean inside their bodies. The salt concentration of human blood is surprisingly similar to that of seawater. It's a chemical fingerprint of our evolutionary origins, a reminder that life began in the sea and never fully left it behind. In a strange way, every wave that breaks on the shore is carrying history. Not just the history of the ocean, but the history of continents eroding, mountains rising and falling, volcanoes erupting, and rain falling endlessly on stone. The salt on your lips is the residue of vanished landscapes and ancient storms. It is the quiet outcome of processes so slow that no human lifetime could ever witness them fully. The ocean is salty not because it was designed that way, but because the planet has been patiently working on it for billions of years. Rivers deliver the ingredients. Volcanoes stir the mixture. Life shapes the balance. And time does the rest. So the next time you taste salt in the sea breeze, remember that you're not just tasting water. You're tasting Earth's memory. A story written, drop by drop, grain by grain, across the vastest timescale imaginable. Thank you for watching. Don't forget to like, subscribe, and stay with us.